All right, so we're back working on section 5.1 about functions of quadratic functions. So we're talking a little bit more about the axis of symmetry. So of course our parabola is symmetric about what we call the axis of symmetry, which will always go through the x coordinate of the vertex. So we will have that is an equation x equals h, whatever the x location of the vertex is. So this one, right, we know this means the x minus 5 means that it's been shifted right by 5, and the plus 1 means up 1 unit. So we know that our vertex should be at 5, 1, right? Because we're basically taking the point 0, 0, and we're saying we're going to move over plus 5, and we're going to move up 1. And there's our new vertex, 5, 1. Oops. Trying to write a parenthesis instead of a 1. And so since our axis of symmetry has to go through that vertex, every point on that dotted line that I drew there, it has got the x coordinate of 5. So we're going to say the equation of that line is x equals 5. All right, so here's another one. We're going to basically do all the same stuff here. So we're going to look at this and say, hey, okay, what does this graph open up? Is it concave up or is it concave down? What's going to tell us that? The coefficient out front, the a value. So because it's negative, we know it's been reflected over the x-axis. And because it is between 0 and 1, we know it has been shrunk, vertically shrunk. All right, so that means that this thing's going to open concave down because our original looks concave up, and we have gone and reflected it and also squished it a little bit, right? So it's been shrunk. Our vertex, where is that? Well, we know we have a horizontal shift, right? That we are going right 4 and we are going up 3. Right, so we're starting at 0, 0. We're going to go 4 to the right, up 3. So our new vertex is going to be at 4, 3. That is going to be a maximum because we do know that it's opening down. It's concave down because it's been reflected. And our axis of symmetry has to go through that vertex, so it's got to be x equals 4. Now, so if we're just sketching this, we're just going to kind of do this. Boom, boom, done, right? Because that's all we really need. If we want to find the x-intercepts, and some of your homework's going to ask you to find the x-intercepts, we need to solve where this is equal to 0, right? Where is the y equal to 0? So we're really solving this equation, right? Set y equal to 0, solve for x. So we can say, okay, subtract 3 from both sides, multiply through by -2. So -2 times -3 is 6. Now we can use square root property. So I can take square root. This is going to be a little bit ugly. Square root of 6, of course, plus minus, and x minus 4 on the other side. So our x-intercepts are going to be 4 plus or minus root 6 because I'm going to add 4 to both sides there. The other option you could have done would have been to go back to the original, spoil everything out, and use the quadratic formula. Now this, let's see here. There we go. Oh. There we go. So here we want to make sure we've got square root of 6 plus 4. That's one of our options. And 4 minus square root of 6. So if we go plot this, y equals -1/2 x minus 4 squared plus 3. I've got to turn off all these other ones. There we go. And we can see if we were right, we're going to go say, hey, where are the roots of my equation here? And it's going to tell me 1.5505 and 6.449, blah, blah, blah. So of course on the test I'm going to say, hey, what are the roots give exactly, right? And GeoGebra is not really going to tell you what that 1.5505 blah 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 is. It's not going to tell you, oh, it's 4 minus root 6. You're going to have to do the math for that. Sorry, guys. Okay, so my sketch there was not too far off. Now the y-intercept, that one's easy, right? Y-intercept, we're going to say, hey, plug in x equals 0. So we're going to say, let's see, so that's going to be negative 1/2. Oops. Do we have any more here? Yeah, we do. Talk about, let's see, y-intercept over here, right? We're going to plug in x equals 0. So we've got negative 1/2. 0 minus 4 squared, that's going to be negative 4 squared, which is 16, plus 3. So we've got negative 8 plus 3, which will be negative 5. So my graph's going through here, here. So we can sketch this a little bit better. Close enough, right? There's my sketch. So my y-intercept, 0, negative 5, x-intercepts, 4 plus or minus root 6 comma 0. What's my domain? All real numbers, because it's a polynomial. What's my range? Negative infinity all the way up to 3, that y coordinate. And 3 is included. Now, where's it increasing? Where's it decreasing? So it's increasing. Let's do a highlighter here. Where's it increasing? Remember, we're reading these things right to left. So I should highlight the other direction, right? So we are increasing from negative infinity to 4. Remember that these are x intervals. And it's decreasing from 4 to positive infinity. And remember, 4 is not included on either of those intervals because exactly 4, it's neither increasing nor decreasing. That tangent line has 0 slope. Okay, and we're at 7 minutes, so we'll stop this one.